Hello all. This video is all about interfacing the input devices to the physical world in embedded system design. So how to interface with the environment or with the physical world through the input devices. So the input devices will usually be a sensor. It can be a sensor to sense the environment. It can be a push button or a toggle switch, MPMT, or it can be a keypad as like in the computer, DIP switch. These are different types of switches. The capacitive touch or the resistive touch, the joystick, maybe the touch screens, rotary encoders. These are the different types of input devices which will be connected with the microcontroller and through the embedded system. So through these devices, either the naturally the input device will sense and it will give the information to the microcontroller, or through switches, the input will be given to the microcontroller. So next one is the environmental input. Environmental input is nothing but the sensing data. It can be a sound sensor. With the help of sound sensor, sound can be estimated and it can be given to the microcontroller. Light sensor, temperature sensor, humidity sensor, pH sensor, and the airflow. So these sensors will sense the data and it will give to the microcontroller, and the microcontroller will give the data to the embedded system or to the control unit. So these are the different types of switches, push buttons, toggle switches, different types of inputs that we give to the microcontroller. So this is the diagram for a connecting switch. If the switch state is on, the output would be high. If the switch state is off, the output will be low. Here, for switch number 2, if the switch state is on, then output will be low. If the switch state is off, then the output will be high. We have a microcontroller which is connected with switch 1 and switch 2 and resistors 1 and resistor 2. So here the microcontroller MSP430 is connected between the resistor and the switch. So the resistor goes top and the switch comes down in the right hand side for switch number 1. But for switch number 2, the switch number 2 goes up and the resistor comes down. So this changes the working principle of the switches. Pull up and pull down resistor values. So here, if the resistor value R1 is greater than VIH, so VIH is nothing but voltage is equal to current into resistor, right? Current is I, resistor here is R1. Here VIL, VIL is current I into L into R. R here is R2. So here this microcontroller, towards the right side, it is having switch number 1. Towards the left side, it is having switch number 2. Switch 2 goes up and resistor comes down. Switch 1 comes down and the resistor R1 goes up. Okay. When the R1 resistor is up, then high input current would be given to the microcontroller. When the resistor comes down, then low input current will be given to the switch. So these types of resistor values are called as pull up and pull down resistor values. Switch bounds with pull up resistor. So here we have the graph between voltage and time. We can find the fluctuations between the voltage and the time. Switch pressed duration, switch pressed. So this is a graph between voltage and current. So this is the simulation actually. Switch bounds can be performed in two means. One is a hardware option and another one is a software option. Hardware option is not usually preferred, but software option can be done. Interfacing to the physical world through more inputs. As I told already, through touch screens, through LEDs, through devices, through external switches, through keyboards, through buttons, we can provide input to the microcontroller. So these are the input devices, as like keyboards, matrix of keys. So here we have switches like S1, S2, S3, 4, 5, 6, 7, 8 and 9. The resistors R1, R2 and R3. One resistor will be controlling 3 switches. Second resistor will be controlling next 3 switches. Third resistor will be controlling the last 3 switches. So port 1, port 2 and port 3. Port 1 will be connected with switch number 3. Port 2 is connected with switch number 2. Port 3 is connected with switch number 1. Switch number 1, 4 and 7. Port 2 is connected with switches S2, S5 and S8. Port 1 is connected with switches S3, S6 and S9. But port 4, 5 and 6 are separately connected with S3, S6 and S9. And all the resistors are grounded. So this is nothing but the matrix of keys. Using analog to digital converter to read multiple switches. Here also we have switches connected with resistors to make the microcontroller connected with input-output switches. So this is a best example for providing input through switches to the microcontroller. I hope you would have learned in this video. This video would be useful for you. See you in the next video. Until then, it's bye from Radhika.